Okay. So we're talking now, we are in the middle of talking about the empirical distribution and how we're going to use it to estimate our random variable of interest. For instance, what's the probability that a certain value of the random variable will be less than a certain number. And we'll be using that, as I said before, in order to develop all kind of estimates for the stability of the machine learning, the confidence intervals, different estimates like accuracy or F1 score or different things like that. So that's the setting. But in order to do that, we need some background on calculations that have to do with the average and the variance. So let's take a detour and talk about them first. Okay, so the first thing, so we started to talk about the expectation of a random variable. And the first thing we want to understand is what is the expectation of the sum of random variables? Okay, so we have two random variables, and we take their sum. So for instance, one random variable is we are throwing the dice, and one random variable is whether the dice came even or odd, and the other random variable is, I don't know, whether the dice is, what's the number, what's the 3 times the number of the outcome of the dice. And we want to find out what the average of their sum is. Okay? So remember, the average of something is simply basically the sum of the probability that something would have a certain value, the probability that x plus y will have a value I, times the actual values that x and y got when we chose I. So the value of x plus y in that case is simply I, right? Is that clear?
Can you go through that last bit again?
Maybe let's start with something simpler. What's the, let's start here. Maybe it will be easier here. So what's the average of a random variable? It's just the sum of its possible values times its possible, the probability of getting that value. Okay? That one is clear?
Yes, that one's clear.
Okay. Now if we have another random variable, so, and let's assume that they get they get values on the same. So they say that the support is the same support. So the places where xi has a non-zero probability of happening are the same, places where yi has non-zero probability of happening. So the probability of the average of y is going to be simply the value of the random variable times the same probabilities, right? Correct? Agreed?
Yes.
Okay. Now let's take the sum of these two things. Okay. So this is the sum that I have xi plus yi times pi. Okay. That's correct?
Yep.
Okay. Now look at this. What is this? How do you call this? This is the average of what? It's the average of the sum of two variables, right? Okay. Does that make sense? This is the average.
So you represent that with E and then X plus Y? Is that how you?
Exactly.
Okay.
So basically, what did we get? If we do plus on the left side, we get this, right? So we got that the average of x plus the average of y is equal to the average of x plus y. Okay? That's what we wanted to do. That's the formula we wanted to get. Make sense?
Yeah. Well, I'm still trying to figure out the top, how you got E of X plus Y equals the sum of I.
Forget about that.
Okay, I'm forgetting about that. Done.
Okay, that's an easier way to think about it. And then I want to say another thing that I want to think about. If I go and I multiply the random variable by a constant, what do I get? Okay, so again, it will be easier to explain it in this way. So again, this is the average. Now, if I multiply both sides by a constant, I get c times e of x equals c times the sum of xi pi. And now I can put it inside. The c I can put inside, right? So it's the sum of c xi pi. Okay? And this is, if you look at this, this is, well, how do we call it? We say that this is the average of C of times the random. Okay? So we get that this is equals to the random variable times C. Make sense?
Yep.
That makes sense.
Great. So this is, we say that the basically this behavior is a linear behavior, and we say that the random variable is a linear function. That's how we call it. Okay, it behaves in a linear fashion. Okay, so that's one thing we need to understand in order to do the other derivations that we'll do later on. Now the other thing, let me start a new one here. We need to understand something about the variance. Some things about the variance. Let me start a new one. Okay. So what is the variance? The variance is this is something we'll need a lot in the context of testing. So we need to develop some intuition about it. It's the average of the distance between the random variable has to the average. So the average of how far I am from the average of the random variable. Okay? Does that make sense? Like a measure of
It's like the distance.
how far I am from the average on the average.
Yeah, that makes sense. Yeah, that makes sense.
Okay, great. Okay, so the next thing we need to understand is, okay, so I can certainly do that, right? I can do that. Makes sense. Just right. That's just you know, a plus b square equals a square plus 2ab plus b squared. And here, in our case, a is x and b is e of x. Okay, make sense?
Yep.
Great. Now we've just seen that e is a linear functional, right? So now we can write it like this. Let me explain. So we have a sum of these three things, so we can sum them, right? That's what we just learned, okay? And in addition to that, you see, this is a constant, it's just a number, and this is a number. So this is the C that we had previously, so I'm taking it outside from the average. So I'm using the fact that we just proved. I'm just writing what we proved. We proved that each of the sum of two random variables is the sum. Okay, and we proved that C times E of X equals E times Cx. So I'm using that, and C in my case is minus 2 E of X because it's just a number. So I'm taking it out. Okay? And then here, this is also just a number, so I'm taking it out, and I'm left with E of 1, which is just 1. You know, the average of a constant is constant. Does that make sense?
So far, so good.
Great. So we just you see, and this is minus 2. So this is now E of minus just a shorthand, you know, E square of. Okay, so that's minus 2 times this plus 1 times. So it's E of X minus. So that's the variance. So the variance of X, this is a definition. Okay, and then we get this. This is something we will use a lot in just the derivation of how we get from the definition to this. So it's the average of X squared minus the square of the average. Make sense?
Yep.
Great. Very good. Now I want to know what is the variance of some constants times X. Okay? So that's equal to the average of C squared X squared minus the square of C squared X squared. Agreed?
Yeah, that looks right.
So what happened here is that I'm using this formula because that's the variance. And I'm just putting, instead of X, I'm putting Cx. Sorry, I need to drop here the 2. Maybe I can erase it. Color. Okay, I should erase them. Okay, so I just put basically I've put instead of x, I've put cx. Okay, make sense?
Yep.
Okay.
Yeah, it makes sense.
Now,
I was gonna ask you about that. That didn't seem right, so that's good.
very good, very good. Thank you. So now the constant c squared and c can go out. So so it's easy. Let me now write it over here just a minute. I have a little bit more space here. So now what I have is that this is equal to c squared. I'm just taking the constant out, right? E a x squared minus, now I'm taking the constant out again, but I have a square, so it's minus c squared e square of x, right? You see this? So here, what I just did is c square went outside, and this is this. And also, here c went outside, but because you have a square here, it becomes c squared. Make sense?
Yes.
Okay, very good. So now, what I have is c squared e x squared minus e square of x, which is equal to c squared, the variance. Just remember that this is the variance. So we have this additional thing that the variance of x of cx is equal to c squared variance. Okay. Make sense? We're just accumulating. We need one more rule, but we've accumulated most of the rules.
Looks good.
It's just in algebra. There's two things. One is to understand the concept, which is the variance, and then you need to understand the algebra. And this is the algebra we've covered up to this is the algebra we need, this and this, and we'll need one more rule which we'll cover next time, and then we'll be ready to go back to the explanation of the testing. Okay.
Yeah, thanks for taking this step by step. It's been
Yeah,
a while.
I think it's very useful. Now you can look at the Wikipedia or any other resource, look average and variance. It will make now a lot of sense. I think you need to see it step by step at least once to feel comfortable with this. It's like high school. You learn some rules. If you just always see them without any explanation, they don't stick. But here you've seen how I get to them once, they will stick and you can reuse them. So
May take
next
more
time
than
we'll
once,
have
but
another
we're
rule.
good.
Good. Next time we'll have one other rule, and then we'll be ready to get on our merry way back to the chapter. Okay. So very good. So thank you very much for joining, and we'll continue next week.
Okay, thanks, Eitan.
Thank you.
Thanks. Bye-bye.